this video today, I'm going to be dealing with calculations involving refraction of light and as it travels from one transparent medium to another, but of different optical densities. So I'm going to be dealing with refraction. So suppose light travels from a vacuum or air. We know that the speed of light in air is 3.0 times 10 to the power 8 per second. Now, if it strikes the interface, for example, and this is medium 1, and this is, let's say this is vacuum, and we have our number here. So it undergoes refraction, so it is bent. So the angle between the normal and the incident ray is angle of incidence, and we're having angle of refraction, which would be R. So out of that, now because of difference in optical densities, you find that this one is optical dense and this optical dense, but the optical density of the vacuum is less than the optical density of, and therefore if refraction, for example, if light is from a dense medium, for example optically dense medium like M1, if M1 was up, and therefore if I'm having this and let's say a ray is incident, you find that it will refract away from normal, and therefore it will refract away from normal. So out of that, you find that this is R, this is I. So you find that out of that, this is because of difference in optical densities. So if a ray of light is traveling from a more optically dense medium to a less optically dense medium, for example air, so you find out of that it will refract away from normal. And if it is from a less optically dense medium to a more optically dense medium, this is refracted towards the normal. So out of that, if you have something of this kind, you find that it will refract towards the normal. So this would be our R. This is like that. So let's go into calculations. You find that as light travels from one medium to another, undergoing refraction, out of that, for calculations we use Snell's law, of which here we say that the sine of angle of incidence over sine of angle of refraction is constant, but this constant is actually our refractive index. And so this is one of the equations that we use for calculations here. Also, so from this, if I have sine R, yes, like would be equals to for example, now for refractive index is represented by a new sign. So out of that, we can say that all over sine of R will be equals to, then out of that, let's take sine R the other side. So sine of I would be equals to sine of R, of which this will be the refractive index of the medium. So this is true due to the fact that the light is considered to be coming from, let's say, within a vacuum. That, for example, this is media net. This is considered to be a vacuum, and the refractive index of a vacuum is 1, and therefore if we are working out, you find that even if I put a 1 there, still sine I is equals to mu sine R. So let's try to apply this into calculations. Now let's have our example one. I'll find the angle of refraction if the refractive index of glass is 1.52. Now here what we are going to do, we know that from our formula we are going to say that if this is taken to be air or vacuum, and hence when we are doing our calculations we know that refractive index of air sine of I would be equals to the refractive index of glass sine of R. Therefore we are going to have, this is going to be 1, and then we are going to have sine of 60 would be equals to, I'll have 1.52 sine of R, and therefore I'm going to have sine of 60 divided by 1.52, which would be sine R, and hence I would have here sine R being equals to sine inverse of sine of 60 divided by 1.52, and R would be equals to, would be sine inverse of 0.5698, which would be equals to 34.7 degrees. Therefore this should be the angle of refraction. So this is how we have used from above to calculate for the angle of refraction. Let's try another example. This example, the angle of incidence of water of refractive index 1.33 is 45 degrees. Then find the angle of refraction. So let's first have an illustration here. So if we have our interface that we are having this, the normal, and the angle of incidence which has been given, we're having here, this is 45 degrees, and it says it and suffers refraction. It's like so this is water, and therefore we are going to have our ray that will be bent. So we're having this as our R, angle of refraction, and therefore, so out of that we know that the refractive index of air sine of I equals to the refractive index of water, in this case sine of R, and therefore we need the angle of refraction. Therefore we are going to have something that's going to be mu1 sine of divided by, we have water which would be equals to sine of R, then R, then sine inverse of the refractive index of air vacuum sine of I all over refractive index of water will give us R. Let's substitute in. So sine inverse of sine of 45 all over 1.33 plus this would be equals to R, and therefore sine inverse of 0, this is 0.5317, so b equals to R. So out of that I'm going to get, it would be 32 1 degrees, which would be approximately equals to r. So out of that, this is the angle of refraction. Let's say angle of refraction when light is incident at an angle of 45 SI on the interface of water and air. Let's try another example. For this example, the angle of incidence is 30 degrees in air and the angle of refraction is 19 degrees in the medium. Find the refractive index of the material. As like this, let me have an illustration. Now the angle of incidence is 30 degrees, then it is refracted in the material medium. So this I'm having here 19 degrees, and therefore I'm to calculate. This is the material medium, and this is air, which has the refractive index of 1. Now this one is lacking refractive index, so we don't know this. So let's do the calculation. We know that if we have the refractive index of air, sine I would be equals to the refractive index of the material medium, that's like sine of r, and therefore we're going to have here, this is sine of 30 is equals to refractive index of the medium, sine of 19, and therefore if we proceed with this, this will be sine of 30 divided by sine of 19. So this should give us the refractive index of the medium itself. Therefore we are going to proceed and say that sine of 1.5358 be 1.5 approximately equals to the refractive index of the medium. So this is how we deal this. For this example, we have been given, let's say, the speed of light in glass and the speed of light in water or in a liquid, but here they have not specified, and therefore let's take it like that. So the angle of incidence I has been given as 60 degrees. Now the speed of light v in the liquid is, we are having 42.4 times 10 to the power 8 meters per second, and the speed of light in glass has been given as 1.92 times 10 to the power 8 meters per second. Now having obtained those, now a formula here that we are most likely to use, we know that also refractive index of a material is given by the speed of light in vacuum or air all over the speed of light in the material medium. In material medium, and therefore this will proceed as, now the speed of light in a vacuum is characterized by a letter C all over V. So out of that, this is the formula that we are most likely to use to get the refractive indices of the two media. So out of that, we know that if I have index of the liquid, sine of I be equals to the refractive index of the glass sine of r, because if I have this and I'm having this, so it is refracted. So this is r and this is I. So out of that, I has been given. So to determine the refractive indices, I'm going to say that the refractive index of the liquid will be the speed of light in a vacuum, which will be C all over V of the liquid, the speed of light within the liquid, sine I would be equals to, now the speed of light in a vacuum over the speed of light in the medium itself, which in this case would be a glass. So sine of r. So that if you look at this goes with this, but we are looking for this. So that I'm going to have, if I make sine r the subject, I'm going to have again sine I all over speed of light within the liquid, and therefore this would be equals to sine r. But since I'm looking for the angle, I'm going to say r would be equals to sine inverse of sine I over VL. And therefore the next thing here, I'm going to say that I'm going to have, it would be sine inverse of, I have the speed of light within the glass and the speed of light within the liquid, 1.92 times 10 to the power 8 sine divided by 2.4 times 10 to the power 8. And therefore if I proceed here, so here I would have this cancels with this, and therefore would have an inverse of 0.6928. Therefore this would be equals to 43.8 5216, which this would be approximately have 43.9 degrees. Therefore this would be the angle of refraction. This is it for this video. Thank you for watching. See you next time.